Okay, moving on to question 2. We have a calculation question. It's very similar to the one in exam. So it's very typical questions where they add calculation as well as deduction to solve a question. So first of all, we have a carbon containing CHO and the relative molecular mass is 102. So they've given 3 tests. So the first one is mostly for calculation requirement. 2 and 3 are mostly for the part B, where you have to suggest a possible structure. So let's finish off A first. Now A is quite straightforward. It's just calculation. So we have 3 elements. So C, H, and O. So we have to use the table. So the way you find empirical formula. So first we need mass, number of mole, and then simplest mole ratio. Okay, so for the mass of this one, we will check it's 0.9 grams for carbon. Hydrogen is 0.15 gram, but they have not given us oxygen, though they have told us that there is containing oxygen. So what we do is we have the total 1.53. So we do 1.53 minus 0.9 and then minus the hydrogen. So and then we will be left with oxygen will be 0.48 grams. So now we're done with grams, which means the mass. Now we find the mole. So in order to find the mole, we need mass over molar mass. Mass is given. Molar mass of carbon is 12. So mass over molar mass will be 0.9 over 12. And then we will have 0.075. For hydrogen, 0.15 over 1. And then we will have 0.15. For oxygen will be 0.48 divided by 16. Mass over molar mass, we will have 0.03. And then we have to do simplest mole ratio. So the smallest one is 0.03. So what we do is 0.075 divided by 0.03. We got 2.5. And then 0.15 divided by 0.03, we will get 10. And then 0.03 divided by 0.03, we get 1. Now you'll notice there's a 2.5. So we have to make a whole number. So what we do is we multiply to the whole equation. So we times 2, and sorry, this one should be 5, my bad. Times 2, and this one should be times 2. So we'll have 5, 10, and 2. Now remember, once we use this, the answer we'll get will be empirical formula. Okay? So do not make the same mistake as you did in exam. So it will be C5H10O2 bracket N. So we have to first calculate N. How do we calculate N? We have to rely on the relative molecular mass of Z. So equals to 102. So what we do is 12 times 5 plus 10 times 1 plus 16 times 2 N equal to 102. So after calculating 12 times 5 plus 10 plus 16 times 2, we will get 102N equals to 102. So therefore N equals to 1. Molecular formula equals to C5H10O2. Okay, so that's how we get 4 marks, or maybe sometimes 3. So now we have deduced this. Moving on to question B. Suggest a possible structure of Z. Explain your answer. Now let's analyze what the test 2 mean. There is no observable change when potassium carbonate solution is added to Z. Now if you remember, anything carbonate will react with acid to give out carbon dioxide and water. Now since they have said no observable change, that means it is not a carboxylic acid. All right, not a carboxylic acid. I'm just gonna move on to the next page over here. So B1, just see. So not COOH for test 2. Now for test 3, yellow-brown color of the aqueous bromine remains unchanged when several drops of aqueous bromines are added to that. Now this is testing for alkene. Now had it been alkene, the bromine would have been decolorized. So therefore not alkene. So how do we, now suggest a possible structure, explain your answer. So for B1, you have to explain it cannot be COOH because there's no reaction with carbonate, so it cannot be acid. You also explain why it cannot be alkene is because it remains unchanged. So you got 2 marks for that. So 1 mark for this one, 1 mark for this one. So you just write it in sentence. Now you have to suggest a possible. So there will be many possibilities, you just have to write down one. So let's look at it again, C5H10O2. Now if it's not carboxylic acid and there are 2 oxygens, so that means they must be separated. So let's look at the possibilities. So we have C, 1, 2, 3, 4, 5. So we have to use up 2 oxygens. So one, I will treat it as, let's say, OH. And the other one, if you think that, okay, why not another OH? So let's try that as well. So another OH over here. So we have O is checked. 5 carbons checked. Now we have to check if there are 10 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 carbons. So it cannot be hydroxyl group, 2 hydroxyl group. So then we move on to the next one. Now of course there are other ways, faster ways to identify, which I'll tell you when I meet you. So let's go back again. So we start with aldehyde. We can start with aldehyde. And then now we can give an oxygen, let's say hydroxyl group. So you can add hydroxyl group anywhere. So I'll just add it at the end of the chain. Doesn't matter. So now let's count. Carbons are fixed. Oxygens are done. So let's count hydrogen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and also done. So that means it's an aldehyde and a hydroxyl group. It can be aldehyde, or you will notice some of you might have given the answer like this. So it can be ketone. This ketone can be anywhere in the middle, and hydroxyl group. It also is acceptable. So as long as you have aldehyde plus hydroxyl group, you are correct. Or ketone plus hydroxyl group, it is also correct. So as long as you got these 2 and you gotta make it like that, you're correct. So give your IUPAC naming. Now for this one, I've not taught you, so I'll just teach you now. We will treat this as a side chain, so it's hydroxyl. So for example, this one will be 1, 2, 3, 4, 5. So it'll become 5 hydroxyl, MEPB. So butanol. Okay. So I'll teach you this one on my own, but till B1 you should be able to solve it. Okay. So that's all for question 2.